Hello everybody. Today we're going to be working on looking at our plant growth experiment lab where we grew either bean or pea plants, and we grew them in water, the hydroponics system, or we grew them in soil, the traditional system. And so if you look down, you can see the pots filled with soil for one part of the experiment, as well as the fact that we had water growing in tubs, the plants growing in tubs of water in the second container and the third container. The lines you see going into this tub are little mini pumps that help circulate the water, preventing algae growth as well as aerating the water as the plants are growing. And so I'll just lift one of those out right now so you can kind of see and hear what it looks like. All right, there you have it. As you could see that today, the 19th of March 2019, some of our plants did really well. In fact, we even have some bean pods ready to eat, as well as, if we go over here, some other plants that have recently bloomed. However, we are going to go through with this experiment to talk about what leaves look like when they are nutrient deficient. They're not getting enough of those macro or micronutrients. So you can see here on the hydroponics plants, we do have some spotting. And when we look at these leaves, you can see that they are a little bit more yellow, and they're also a little bit wrinkly. They're not as smooth as some of these older leaves that we were seeing growing on these plants. Here's a look at some of those symptoms that you're seeing in the plants that are in the soil. Now, some of this could be due to when we transplanted them, the leaves getting a bit damaged, but for the most part, a lot of these are going to be due to nutrient issues. So here is just another final view before we start going through and collecting our data. Here's the setup for our experiment. Now, for your materials and methods, you should make sure that you include a tub of water. We're going to be using that tub of water to rinse the soil away from the roots of all of our potted plants. On the table, you can see an example of one of the plants. That's one of our beans that we are using. You'll also see that we are going to be using a measuring stick, and it is on the centimeter side because remember, we're doing everything in metric. We have a scale, and that scale will be measuring everything in grams. We have a pencil or pen. We have a data table, and we have scissors because we are going to need to cut the root away from the stem or the root and shoot system in order to fully measure each of those separate halves. For this experiment, we're going to have multiple things listed. We'll make sure on our data sheet we have the group name, the plant species, beans or peas, the medium, which is soil or water, the shoot length, the root length, shoot weight, root weight, the number of leaves on each plant, and flipping the page, we'll see that we'll also have overall plant health. In other words, if the plant is showing some wrinkly leaves or some spotted leaves, at that point we'll make sure to write it down. The first thing I'm going to do with this plant is remove the flag. That is what the plant has been growing up. And then I'm going to unpot it over this pot right here to get rid of any of the loose soil that's going to fall off. You can see here that before I even take out any of the soil or touch it, that there are a number of roots that are holding this entire pot of soil together. Here you can see me gently manipulating the soil to start to knock some of that soil off the roots, but I want to do it really, really gently. When I'm not videotaping this, I will actually be using two hands. Here you can see I have gotten rid of some of the loose soil. At this point, I'm going to move it over to the bucket of water. All right, into the water it goes. And once we're over here, you can see how the rest of that soil just comes off really, really easily. Again, easier to do with 2 hands, but we want to see every step of the process. So I'm moving it around in the water. And because we use potting soil, this will get away from the roots really easily. Although that perlite, the white balls, seem to be sticking quite nicely in here. And voila, look at all of those roots that were in that water. Another item to add to your list of supplies or materials is paper towels. You can see that the roots off of this bean plant are quite wet, and we want to get the weight. So I want to take some paper towel and blot it dry. Also, with that paper towel or a separate one, I can go and say like, hey, you know what, these leaves hit the water a little bit. Let me just blot those dry also. In this way, we can see that we can lay out the plant. The total length of the bean plant we've been using for this demonstration is over 1 meter long. You can see that with the shoot and the root, these plants can grow quite large, even though they were in only 4-inch round pots. Now the marker at the top is just to hold the stem in place, otherwise it will curl up a little bit, making measurement more difficult. The first thing I'm going to measure today is going to be the root system on this bean plant. When I look at it, I need to determine where is the top of the bean root. And to do that, I'm zooming in right here, and I'll see that the bottom of the stem, the part that was underground, is white, and I can see roots coming off that structure. That is what we are going to count as part of the root system. Whereas if I move to where the shoot system is, you can see that that stem portion is green and photosynthesizing. Here you can see that I have carefully extended the roots so that the longest root goes to the bottom of the meter stick. And when I go to the top part and I look at where the roots start coming out, which is right about here, you can see that that is at approximately 27 centimeters. And so that's what I'm going to write down on our data sheet. So on this data sheet, this bean plant has a root length of 27 centimeters. To measure the stem system or shoot system, I have repositioned the measuring stick at the base of the shoot, the part where it starts to turn green and right above the roots. And then I've extended it all the way to the top of the plant, way over here. And if we zoom in, you can see that the stem part itself is 96 centimeters long. Wrote down 96 centimeters and that the top was broken. That way, if the plant is very off from the other bean plants grown in soil, I'll know that that's probably it. However, it should be mentioned that it looks like maybe just the top centimeter or two, if I had to hypothesize, was actually missing from this plant. Now comes the part where we're going to use the scale. You can see I've turned on the scale and it says 0.0 G. That's in grams. That's what we want to use. And you can see here I have my scissors all set up in order to cut off the roots. These plants are going to die. So I take the scissors, I've put the cutting edge right at the base where those roots are coming out, and I snip it in half. I then can take out this root mass that I have already pre-measured and pre-blotted, and I can put that on top of the scale. Now when I do this, I want to make sure I have all the roots. So I go back and I examine where I did the cutting, and oh look, here's a little piece of a root, here's a piece of the root. Okay, so I want to make sure that I get all of those little pieces on top of the scale. Now when I look here, oh look, those roots weigh 5.5 grams. That's what I'm going to record on the data sheet. Here I'm doing the same thing for the stems. I made sure they were blotted dry, and then I laid them on top of the scale. Since the plant shoot is so long, this one was almost 1 meter in length, you can see I've had to kind of ball it up in order to make sure that it fits onto the scale. and its total weight was 13.4 grams. Looking at these leaves, overall they looked pretty healthy. The tears were just the abuse the plant took as I was doing all my measurements. But you can also tell that some of the older leaves off to the right side of the video are very dark green. And then we started to get lighter green leaves. And when I zoom in, you can see that this leaf is starting to turn much more yellow. And you can see that the veins are fairly yellow in between, whereas this other leaf that's a bit older has much more green in it. The question you're going to want to ask yourself about these leaves is, could any of this be caused by nutrient deficiencies? While I would not normally remove the leaves, we did want to count them, and I thought this would be the easiest way to see the leaves on our bean plant that we are using for this demonstration. When I look, I'll see a total of 16 leaves. Since bean leaves typically come in groups of 3, that means somewhere along the line we lost 2 leaves. There were a few leaf buds just starting to open up on this bean plant, and we've decided not to count those as part of the leaf total, only when they get a little bit bigger and you can tell they're distinct leaves, such as this one right here. When I look at the leaves, I can see that all 3 have unfurled, which is different than from my leaf bud example right here, where you can see that those 3 distinct leaves have not yet unfurled. When all the measurements have been taken, these leftover leaves, stems, and roots are getting tossed into a pot, and they're going to be taken outside to the natural area on the CSU campus, and they will be composted. We are using the same procedures for the pea plants, and you can see just from this example, the pea plants do not appear to be holding the soil in place quite as well as the bean example we just watched. Because the roots were more delicate on this pea plant, I had to make sure that I did gather all of them as many broke off. But you can see I still was able to lay it out, and when I zoom in, you can see where the roots meet the stem, and that's at about 22 centimeters. So that's what I'm going to write down on this sheet. Root length, 22 centimeters. So definitely did not make as many roots, it appears. When I go ahead and I move the ruler in the plant so that I can measure the shoot, when I stretch that out as much as possible, I can actually see this plant put much more energy into the shoot system because we actually go beyond the stem. When this happens, I would mark off with my finger where the 100 meter mark was, and then move the measuring tape to that particular spot and add the 2 different parts together. When I look more closely at the pea leaves, I will see that these, the oldest ones, do look a little damaged, but they have been around quite a bit longer and could have been damaged during transplanting. Whereas these, some of the earlier leaves, I can see are undamaged and seem to have been growing pretty well. I'm not really seeing any spots or odd yellowing like I saw on the bean plants. When you look at where this one bean leaf connects to the stem, you will see that the bottom portion actually curves around the stem. Okay. And then the rest of this leaf, which are often called leaflets, extend further up. And I've arranged it so that you can see the lighter green underside of the leaf as well as the darker green top portions of the leaf. Remember, think about what photosynthesis needs and where it would want to put more of its chloroplasts when the plant makes the leaves. You will see at the end of these pea leaves, as well as structures from the bean plants, you'll get these tendrils. And these tendrils are what the plant is going to be using to grasp onto sticks or other upright structures. In the case of our lab, we used flags. So they were climbing up the stem of the metal flag using these structures. When comparing the mass of the pea roots to the bean roots, we can see a big difference. This pea has a mass of 1.0 grams, while the bean plant we saw had a mass of 5.5 grams. Now I'm going to switch these around and going to put the stems up here. And when I look at that, I see that the stems also, the shoot system weighs a lot less also. This pea plant weighs 2.4 grams, whereas the shoot weight for the bean plant was 13.4 grams in our demonstration. On this pea plant, you'll see that you have the leaves that surround the stem, as well as the 4 other leaflets that make up this particular plant. You can see with this bean plant that some are damaged, probably during transplanting, and they didn't grow very well. And so this is as tall as this one grew. Much, much less than many of the other bean plants out there. Here we can see the plants. We can see roots coming out of the bottom, and as we travel upward, we can see the pea plant. When we look at the plants grown in water, we can see that they did grow rather long, and that their root system is looking pretty good, especially on this pea plant. You can see that we had wrapped it in the batting with our name tags in it, and I will now unwrap it and then do some measurements. As we unwind the batting, we can see that the roots can become fairly embedded. As we unwrap the batting, we can see that the plant material can become woven into the fabric of the batting, and we just have to remember to remove that gently so that we can preserve as many of the roots as possible. When we compare the roots of the pea plants grown in water on the left side and grown in soil on the right side, you can see that there are some large differences. The hydroponic roots are definitely thicker, while the roots grown in soil are thinner. And the roots grown in soil have many more side branches than the ones grown in water. While the roots on these plants should grow downward, in this case, this particular pea plant did not have the roots initially drawn through the hole at the bottom of the container. And as you can see, the roots did still grow, but they grew in a circular pattern inside the container, not down into the water straight like we just previously saw. Well, I have to say the bean roots look a bit more jungle-like when you compared them to what we saw with the pea plants, and overall they seem to be growing rather well. So let's compare the roots of the bean plant grown in water, which is closer to you, and the one on top is the bean root grown in soil. Look at the difference in length between the two plants. The roots closest to you are grown in water, and the roots further away were grown in soil, and you can see quite a bit of difference. The one grown in water not only was much longer, but also has thicker roots like we saw on the pea plants, and in addition they tend to be more yellow looking than the ones that we saw grown in the soil, which are much more white looking. When we look at the bean roots grown in the soil, we can see that they are grown much more densely clumped than the ones that were grown in water. When I look at the bean plant grown in water, I can see a much more linear appearance and much less bunched. This could possibly be due to the extra room that these roots had to grow in the water container. You can see on this relatively new set of leaves on this bean plant that was grown in water that there is some damage to the leaves. The leaves are a bit more see-through than you would normally have. So that is the look from both the bottom as well as the top right here. This plant that we're looking at was a bean plant grown in water.